Thanks for inviting us. We are layer 9. We have been working on data observability using Istio as our foundation. So we are very happy to be here telling you what we have done. We have used WebAssembly as a core technology to do a lot of these things that we're doing. So we'd love to share our experiences building a WebAssembly filter. Now, our vision is not very different from Istio's broader vision, which is provide observability, security, and privacy out of the box based on kind of deep understanding of the data plane. So our kind of the key, the key technique that we're using is actually going pretty deep in terms of understanding the network traffic that services are using to communicate, and use that to derive pretty deep insights into how services are performing from a security, privacy, and observability point of view. And let me actually give an example to describe the kind of differentiation that we have. So, if you look at services communicating with each other, the APM tools today look at kind of the requests and responses, and out of the box, be able to provide metrics like request volume, latencies, and response codes. So Istio today, comes with built-in dashboards out of the box that can tell you between any pair of services what's the traffic volume, what's the latency, and what kind of response codes are we getting. But by kind of looking at the data plane itself, we can actually draw much deeper insights into what's happening. For instance, services often have logical endpoints. So everything, all the dashboards that you see in Istio could become a lot more powerful if you can actually split them by endpoints. That does require us to understand, in some more depth, what's happening with the request responses, what are the URL patterns. So use some intelligence to understand what are the logical endpoints. We should be able to look at what kind of authorization is present, what are the API keys, are they being rotated, are they shared between environments? So we can understand authorization in a much deeper level. Endpoints have schemas, they have specifications in terms of what kind of requests they accept, what kind of responses they give. So we should be able to construct your entire API specification and down to the field level and understand the types and be able to kind of detect when those change. People are very interested in understanding services from privacy and security point of view. So understanding, looking at data plane, we want to actually look at what kind of sensitive data is present in each field and be able to tag your endpoints and services with what kind of data are they exchanging. And then, today, a lot of application metrics are manually injected, but looking at the data plane, we should be able to look at pretty rich data metrics at the schema level at each endpoint. So the vision at layer 9 is to really understand the network traffic deeply, to understand how services are communicating, look at the payloads, and then derive a lot of very deep, rich insights in terms of how they're performing. The core foundation we are using is basically a way to understand payloads, and we have an EnvoyFilter that lets us asynchronously sample a bunch of requests within your entire mesh. So the rest of the talk is about how our experience is building an actual WebAssembly filter. I will hand over to my colleague Chandler, who is going to describe our WebAssembly filter, and then at the end, I would actually give a live product demo to show how this actually works in real life.
Thank you, Nilesh. And I'll be calling on Nilesh to change the slides, because if you try to change who shares the screen, clearly, it's 2021, we can't do it. So this slide saying we need to capture the data. So the natural Istio extension point is an Envoy filter for us because we do care about things like the HTTP request body. We care about TCP as well. So if you're talking to Kafka, layer 9 wants to see, what did you write to Kafka? What did you just read from Kafka? And if you're going to have an Envoy filter, WebAssembly is, exciting because it's shiny and new. It's not generally available, is my understanding still. So many times along the way, we felt like we might be the first people trying to really put an AssemblyScript WebAssembly filter in production. AssemblyScript was the second language we chose. The beauty of WebAssembly, you can write in any language you want, except not really, but a few years from now, maybe any language you want. Right now, probably TinyGo, Rust, C++, and AssemblyScript, because if you choose a language other than those, you're going to write your own proxy runtime. So your WebAssembly, in order to look like a beautiful C++ program, it needs to rely on somebody else's library that's going to speak to the application binary interface that Envoy is presenting to the WebAssembly virtual machine. So when you compare WebAssembly to Lua, which is the first thing we tried before WebAssembly in Envoy in Istio existed, in Lua, you're going to have more trouble saying complex things because of the language Lua and the libraries available to you. And Lua is a different way to think about filters. It's not the way an Envoy filter implementer from the C++ native C++ world would think about it. It's a little different, and it's going to be HTTP only. WebAssembly works for TCP, HTTP, both. UDP theoretically. Next slide. So I mentioned like there are native C++ Envoy filters, but then you're maintaining an eternal fork of the fork of Envoy that Istio uses for Istio proxy. And then how do you get that to, how do you deploy that to production? Well, at the very least, you're going to have to, build your own fork of Envoy and build a Docker image around that and tell Istio use this Docker image for Istio proxy, not the standard one. So if you want to try your filter and then stop trying it, not so easy compared to WebAssembly, where we can really just tell Kubernetes, here's an Envoy filter custom resource, and Istio tells every Envoy, run this WebAssembly. There's this other mechanism, the external process, but it's HTTP only. It doesn't seem to be very polished. I don't know if it's generally available, where you can do gRPC to an external process. Lua is, the first thing people tried, and apparently they didn't like it because now there's WebAssembly. It just seems like a kind of a dead end at this point. No one's ever going to put TCP support into Lua because there's WebAssembly. It's the way you would do it from scratch. Next slide. So now you're going to hear what happens if you actually try this when we tried this, which is over the past year. I think the first experiment with Lua was somewhere around Istio 1.3 or 1.4. Next slide. So Lua, when Nilesh first tried it, our filter needs to make a HTTP or gRPC call to the layer 9 service. If you're a customer, you install two Helm charts, one for the Envoy filter, one for the layer 9 service. And to make that call at first in Lua, it was a synchronous call, which was highly suboptimal. But nowadays, the call is asynchronous, so Lua gets the job done for HTTP well enough for us. And we have a filter that it just observes, basically. It doesn't modify things, it just observes things. Lua can modify at least some things, maybe all HTTP things you'd want to. Next slide. So I was the first one at layer 9 to try WebAssembly, and I tried C++ because a dozen years ago I was very good at C++. I don't know Rust. I know Go, but the TinyGo support, it's like, well, TinyGo is not really Go, and it just, people had written some things in the docs that made me think, I don't want to do this in production, not really. I'll use C++, battle tested, it'll work. And it will. I now know how to make it work, but when you're just starting out, the first thing I tried was basically the add a header example, and everything I tried was an instant segmentation fault. Once you could figure out the plumbing to get the WebAssembly bytecode to Envoy, Envoy would crash, segmentation fault. And it wouldn't say, here's the problem with your C++ program. Here's a stack trace from the C++ program you wrote. It would give you a stack trace from Envoy, and then you'd say, what did I do wrong? It was not very friendly. And this could have been because I was using Istio 1.5, even though that wasn't the latest thing available at the time. But we had a bold vision of, let's just write one WebAssembly filter that'll run on all versions of Istio ever, because we want more customers, not fewer. So the more versions of Istio we support, the better. It turns out at the time, the very latest and greatest also would not give you WebAssembly backtraces. So you'd have to hope that your C++ Envoy backtrace would clue you in as to what you did wrong. Next slide. So let's try AssemblyScript. So why AssemblyScript? I don't know Rust. TinyGo seems like people don't really use that. I'll just try AssemblyScript. So Nilesh wrote an AssemblyScript filter that didn't segmentation fault. I mean, it did it first, because anytime we would call an ABI, let's say we passed in a null for an argument to this function, Envoy would crash. That just seemed to be, just doesn't matter what function you call, Envoy is just going to crash. But eventually he made it work for an HTTP call. So that's the Rubicon for us. We need a filter. It needs to make an HTTP or a gRPC call. So we said, well, this is a little scary because eventually this needs to run without, crashing the sidecars in your service mesh, but let's go. So when you're writing an AssemblyScript, we started at AssemblyScript 0.9. AssemblyScript is a new language that's made just for WebAssembly. It's not a subset of TypeScript, but it kind of seems like it. And it's moving fast, the language. So AssemblyScript 0.9, you had some very ugly TypeScript because it just didn't support a lot of TypeScript language features. But that's fine because we have this nice proxy runtime written by solo.io that would hide a lot of that from us. The version of AssemblyScript, if you changed your version of the proxy runtime, you were going to change your version of AssemblyScript. They were married. We noticed this isn't much bytecode. C++ was generating a lot more bytecode in the .wasm file. So AssemblyScript is making something tiny. And C++ was a Docker image to compile. It ran in Scripton and who knows what else to generate the WebAssembly bytecode. And it took forever, and long enough that I thought, well, I'm going to have to set up a build machine for this. I tried to cache the standard libraries and things like that. It was slow. AssemblyScript was fast. It didn't use the Docker image at all. You npm installed AssemblyScript and you built your WebAssembly bytecode. So that was nice. Next slide. So as I say, if you try to call a function on Istio 1.5, say, the first version that had WebAssembly support, if you're not perfect, then you get a segmentation fault. You don't get an error message. Your WebAssembly virtual machine doesn't get terminated and the sidecar soldiers on. None of that. This is different than today. It's not as different as I would like, and maybe that's part of why, as far as I know, WebAssembly is not generally available just yet. Next slide. So why the focus on 1.5? So we don't need to do much. We like the original ABI. So if you run Istio 1.5, it's got a different WebAssembly ABI than Istio 1.6, which is different than 1.9, which is different than, so these ABIs, they are versioned, they change. They're not perfectly versioned and they're not very well documented. So you have to basically read the source to figure out what has changed between these versions, but they are versioned. But we're fine with 0.1.0. If we can, we want to write just one WebAssembly program for every Istio version ever made. And our hope is that, you know, Istio 2.0 will still support the ABI 0.1.0, which is where Istio 1.5 was. So we're going for universality. And if we don't have that, then there would be some challenges, because that would mean, so if we had to have forks of our program for different Istio versions, we would have to have different versions of the proxy runtime, and that would mean different versions of the AssemblyScript compiler. And so we'd probably have to change our program to work for different versions of the compiler. So we'd like universality for many reasons. Next slide. So this is about AssemblyScript's runtime. It had a bunch of functions for TCP, UDP, the network filter support as opposed to HTTP filter support. Except it didn't have all of them connected, which was another clue for us. Like, maybe we are the very first people trying to actually put an AssemblyScript WebAssembly filter into production. It only took a dozen lines to add the other half of this bridge, and that's been merged upstream, and things are good, unless you want to do gRPC. gRPC is still not good, because the original ABIs for gRPC, they sort of require that your program can create and manipulate protocol buffers, which if you're in AssemblyScript, no, you can't, unless you write your own protocol buffer library. And AssemblyScript was written by the same person who wrote the most popular JavaScript protocol buffer library, and that person has not written anything for AssemblyScript. So, you know, maybe it's impossible. It's not, it'd be a lot of work. So it doesn't exist. So if you want to do gRPC, you should probably use C++. Maybe you can do it in Rust. Maybe you can do it in TinyGo. I wouldn't do it in AssemblyScript because you'd have to write your own support for that. But TCP, it works very well. Next slide. So when it was working for the easy cases, it was time to see, you know, let's shake all the bugs out. So let's load test it. Let's stress test it. Let's chaos engineer it. Let's try to break it. So you do things like take down the layer 9 service. Just, it doesn't exist on the cluster right now. Make an HTTP call to it. What happens? Segmentation fault, cry, change your code, file the bug. So just, there was a lot of time, you know, trying to get this to the point where we could actually ask customers to install this filter. A lot of time, and there's some things we still have to work around for certain versions of Istio. So we got to a point eventually where we like it. We like it a lot. It does, you know, we carefully monitor our test beds for crashes, and it doesn't crash. It hasn't crashed in a long time. But this was a painful process, in part because when you have a crash, You don't have a backtrace from your language because we were doing this work before the backtraces for WebAssembly existed, which I think was Istio 1.9. So without that backtrace, how do you figure out what's going on? Well, you have to figure it out from the Envoy C++ backtrace. And we tried to get core dumps and poke around in GDB. That turns out to be hard. To get line numbers, there's a script like stackdecode.py. Well, it turns out you have to build your own Envoy Docker image if you want to try that. So even that is a lot of work. So just to figure out what went wrong, a lot of work. Yeah, this will definitely be easier in the future. My hope is that in the future, not so many segmentation faults, and instead the virtual machine essentially gets deleted if your program does something that upsets one of these functions you can call, like please start an HTTP call. Next slide. So once you have your line numbers and your C++ Envoy stack trace, just to figure out exactly the source code I was looking at, well, that definitely depends on the Istio version, right? So for 1.5, I think they were using github.com/istio/envoy, which if you look at it today, the blurb about it says this is just for developers for some testing, but I think it was like the real repository for cutting the releases of 1.5 and 1.6. So you have to find all the repositories. The WebAssembly support was upstreamed somewhere in the middle between 1.5 and 1.9. So nowadays in modern code, it's in proxy WASM CPP host is a repository that has much of the interesting code. And so just figuring out like the right set of code to look at is a challenge. And if you want to build your own binary so that you can really, really get to the bottom of that crash, so that maybe you could, you know, make Envoy hardened against this, submit a pull request, like that's a lot of work. Next slide. And then a function that didn't segmentation fault, but returned essentially like not found when it should have found something. We just wanted to get some properties. And if you read the documentation for that, you'd probably be surprised to learn that in WebAssembly, you have to insert some null characters in your strings to dig into protocol buffers. So if there's nested messages like A nests B, which nests C, then you're going to need A null, B null C. And so even the things that you can do with it, not everything was easy and documented properly. Next slide. Oh yeah, and after we thought it was, finally it stopped crashing. It does what we want. Can we release it? Can we ask customers to run this? Even at that point, it's like, well, we've invested significant time and we still may not be able to release this until a future Istio version because we've got a memory leak. The memory leak, if you just do the harshest load test you can and hammer Envoy again and again, then in something like a few minutes, it would go a gigabyte of memory up, which is not good. So the WebAssembly virtual machine in Istio today, it's all V8, and there's no way to customize anything about the memory. There's also, if you have a memory leak, one proven solution is we'll just restart the program every now and then. Every Monday we need to restart this service because it has a memory leak. Well, you can't do that because there's no ABI for quit, I give up. So your filter is going to run until the Envoy filter Kubernetes object is removed or changes. So even doing something like reverse uptime, which sounds like a fancy way of avoiding solving the real problem, even that would require like a Kubernetes operator to mess with Envoy filter custom resources. So we were very motivated to fix the memory leak. So we already had a fork of the proxy runtime for AssemblyScript. So we just updated it to use a bleeding edge version of the AssemblyScript compiler that had an entirely new garbage collection system, or so it seemed from the docs. it didn't take many, it was just a few lines of changes to the proxy runtime to use that. No more memory leak. Okay, woo. All right, next slide. So once you have WebAssembly bytecode that works very well for the versions of Istio that you care about, how do you get it to them? So when we were first getting into WebAssembly for Envoy, there was the Solo.io had WASM, W-A-S-M-E, which had a Kubernetes operator that would help you deploy your bytecode. And we were hoping to avoid that because that's another thing, another dependency, another thing you have to ask customers to install, another company you have to ask them to trust. There is some work in recent versions of Istio to just give Envoy a URL for some bytecode, but we want to support some older Envoys. So back in the Lua world, you can put your Lua script inside the EnvoyFilter Kubernetes object. You can kind of do the same thing with WebAssembly. You can put the bytecode in line. You're going to run into like a 1 megabyte limit. So if you've written a C++ program that uses the full protocol buffer library, that's going to be over 2.5 megabytes. So you can't do that. But since our WebAssembly bytecode is less than a megabyte, that'll fit in Kubernetes. So we just inline it. It seems to work pretty well. No extra dependencies, but we look forward to the future where the Envoy proxy can just grab it on every version of Istio that we care about, which is probably like every version of Istio after 1.4. Next slide. So testing your WebAssembly program depends on your language. If you're in Rust, Rust has WebAssembly in the blood. There's a core Rust team all about WebAssembly. I'm sure it's very easy to test your WebAssembly program. The only problem is you're going to have to mimic Envoy. All these ABIs, how do they work? How does Envoy call into your filter? You've got your root context, your stream context, and it depends on whether it's HTTP or TCP. And so you might get it wrong when you're mimicking Envoy in your tests, but it would be straightforward. For AssemblyScript, there is AS-PECT aspect for unit testing. It's like JavaScript's jest framework stylistically. We use it a little bit, except it's such a pain to try and mimic Envoy and just to mock these functions. I think I'd have to spend another day with Aspect to really get there. So testing is a challenge. GA is general availability. Someone please correct me if I'm wrong, but I don't think we're there yet. And part of that might be because of the edit, compile, segfault, cry cycle. I hope that's part of it. I hope that Envoy just soldiers on and politely deletes a virtual machine, which gets to fail closed, or is it called fail open? Anyway, there's a setting where you can say my WebAssembly filter, if it has a problem, just keep going Envoy, which is what we would want to do. Some people don't. It doesn't work the way we would like it to, because most of the problems we would have would end up in a segmentation fault in the C++, which means Envoy can't run the code that gracefully recovers because Envoy's not running. It has crashed. The malicious WebAssembly bytecode. I was reading a GitHub issue where an Istio or Envoy developer was saying, well, in the future, we want to support, we want you to be able to run even malicious WebAssembly without having to worry about it. And when I read that, I was like, oh, I hope this is right, because right now, benevolent programs edit, compile, segfault, cry. So if you can, if in the future you can handle even malicious WebAssembly, then that bodes well for trying, to write your own benevolent Envoy filters. And I will say nowadays, if you're using the latest Istio, then yes, you get your backtraces from your AssemblyScript program or from your Rust program or TinyGo, depending on their language's runtime. But hopefully in all languages, so that's nice. And I actually don't know the next slide. I should probably know the next slide. So now is when Nilesh distances himself from my remarks and gives you a product demo.
Thank you, Chandler. I think WebAssembly, it was hard work, but we felt it was totally worth it. We now love WebAssembly. We have stood on the shoulders of some pretty great communities around Istio, Envoy, and Solo. So we were able to actually kind of get to a point where we're happy shipping this for customers who are running it, in pretty much all versions starting from 1.5. So I wanted to quickly show you how does our end product look like, and in terms of delivering some of our promises and in getting kind of deep visibility in your services. So this is our UI. So we have WebAssembly filter that ships samples to our local data processing pods, which kind of convert those into some metadata, and that powers our dashboard. So this is the end result of it. We have our own sandbox showing a bunch of services. Right now, you're just seeing a list of all the services in our cluster. I mean, this so far might look very similar to a dashboard you might see on Istio. There are a couple of differences I would point out. One is that a lot of our customers want some kind of cataloging capabilities where they can actually curate a lot of content around this. People want to tag their services with teams and owners, add runbooks, wiki pages, basically use some kind of a central database to get all kinds of information in about the services. So we have built some cataloging capabilities here. And then a lot of our customers want to get a lot of external tool signals about the services into a central place. Here you can see a CI integration that tells us when was a service last deployed. And we also get in, alerts, events from tools like your Sentry and PagerDuty and other kind of DevOps tools you might be using to get like a central place where you can see all your problems in your services from kind of multiple tools. This is kind of the same view graphically, which is basically Kiali, except that this kind of like plugs into some of our detailed views. Like in the future, if Kiali has an API that lets us actually build applications on top of it, we'd love to kind of bank on those. But for today, we have something that displays this, where that can hook up to the rest of our app. The other difference here is you would see, so since we look at the data layer, we can actually go slightly deeper in terms of understanding dependencies. Like here you're seeing a service that's writing to a specific Kafka topic, product payment action, and then someone else reading from it. So a lot of this asynchronous dependencies through either caches or queues or even databases, we're able to kind of highlight those based on kind of understanding the data. A lot of our customers have dependency graphs, which are pretty much driven through asynchronous computations, and they really want this kind of dependency graph that can take you through some of your asynchronous edges as well. And then we highlight services where any of the our own system or third-party integrations might indicate an alert. So let me actually go deeper into a service. And now here you would start seeing kind of the differences in terms of how detailed we can go in terms of observability. So first you would notice endpoints. there are like 4 endpoints that we have discovered based on some clustering of all the requests and responses, including an endpoint that has some kind of URL pattern. And then we're able to kind of show throughputs and latencies segmented by your endpoints. We have an activity feed that can tell you what's happening to this service. And we pull in kind of events from tools like PagerDuty, CI, Kubernetes. We can tell you an overall health status from kind of multiple sources and kind of local dependency graph. Here, it says that the throughput and latency looks fine, but there's an anomaly in the data itself. So let me actually click to this endpoint. So first of all, you would see that this endpoint, we're able to pull out the entire schema of how the requests look like, including kind of the structure in it, the field names, the types, and what kind of personal data is attached to each type. So it's a pretty deep API spec of what this endpoint provides, what kind of responses it gives, and what is the structure of the responses. We are able to actually go and look at metrics around each data element. Here, there's one element that's red. And if I look at it, there's a uniqueness metric. So emails were kind of generally pretty unique. And then it has dropped down to 0, which means you are basically seeing the exact same email. It probably means it's like null or empty string. And we've detected this anomaly at a data level, which we're flagging out. So these are kind of like deep insights we're able to kind of pull purely out of the box with using Istio as the backbone. And we do have detected authorization based on the bearer token here. So this kind of tells you some of the capability of what we built. And then let me quickly show you another example, which is a cloud service. So here there's an endpoint which has a classic kind of HTTP error. And if I go into it, and I can see here that this used to return 200s, and now it has started returning 500s. So what we can do is we can actually overlay events that include deployments, changes in other services, PagerDuty alerts, and we can rank them by their correlation to this incident and can rank order them. And here it says that the most likely event is a schema change. And if I actually look at this event number 1, it shows me that the requests have changed the schema, and there are 2 new fields added, and that correlates perfectly with the 500s you're seeing. So it makes it very easy to understand why you are seeing something anomalous. And even if that change came from some downstream service, you get this kind of visibility here. So you can go and look at the dependency upstream that caused it. You can go to that service. You can look at the owner of that and maybe contact that person. That is a kind of whirlwind tour of the product. Let me kind of get back to the slides. So yeah, that's our demo. You can try it out if you are running an Istio cluster, and would love to see if you have any questions around either our WebAssembly or the demo.